Hello guys, I'm starting a new series of lections about object-oriented programming. As an illustration, I'm gonna use C#, but the topics I'm gonna discuss are technology and language agnostic, which means that the same rules apply in other technologies. So I wanna first say welcome, not because I'm a Buddhist, of course I share some of their ideas, but Dalai Lama has a beautiful smile and it gives me very nice feeling. And without any further ado, I'm gonna show you this picture, which brings me a very nice feeling, and I'm thinking I'm in a alien planet, maybe in Pandora. James Cameron created a very nice movie, Avatar. And look at the picture. Probably some of the objects, not some of them, maybe all of them, and the entire picture was created with a 3D software. And this is my world. This is what I imagine when I start working with objects, when I start programming. Oh, the color scheme has been changed to my window, so I just will continue and we'll see how that is gonna affect us. In any case, I like this picture and I just wanna leave it as it is right now. So object-oriented programming is a way of thinking. This is how I wanna start, and I immediately want to back off a little bit. I wanna start from the beginning. So the first computer, actually the CPU is not smarter than a cockroach. The CPU and microcontrollers are very stupid. What happens when we power on a machine? Actually, the CPU goes to an address, retrieves the command from there and executes it. And what usually happens is we have to put the CPU in an endless loop. Otherwise, nothing's gonna happen. For example, if we just have to add accumulator A and accumulator B and record the result in accumulator C, this is gonna be done if this is the command, the first command, and after that the CPU will stop working. So we have to enter an endless loop. The next thing which I wanna talk about is the binary code. Every CPU or ARM, Advanced RISC Machine, has an instruction set, and the instruction set are binary commands. Initially, when we started programming, we were using binary code, and this wasn't very useful. Can you imagine how difficult it is just to look at the zeros and ones, the binary code, and send instructions to the CPU using such a method? In the beginning, yes, this was used, but not for very long. The people very soon realized that this way they cannot create serious programs. They cannot create actually anything serious. So the assembler was born. We delegated actually translation to somebody else. Okay, so what we did actually is we started to use mnemonical commands which are closer to the human language. And for example, if we have to add accumulator A or register A to register to accumulator B, we use something which is similar to the human language. We use a command add. Or if we have to move, we use command which is MOV or something like that. So we are getting closer to the human language. We make it easier for the human beings. After that, the high-level languages actually have been born. Fortran, Pascal, Ada, and so on and so forth. Let me go back in the history. The people since the beginning were thinking about how to create a virtual reality, how actually to create a model of the real world and put it in the computer. The language like Simula was born in the 1960s. The language Simula was born. I know for one particular version, Simula 67. A guy by the name of Alan Kay actually was inspired by this idea. He was a visionary guy. He had the vision for building a personal computer with a graphical user interface. He started to experiment with Simula. He was inspired by this language, and he is the one who first used the term object-oriented programming. Back in 1967, as he says, somebody asked him, "What are you doing?" And his answer was, "I'm doing object-oriented programming." Okay. Okay, so object-oriented programming. He sold his vision to Xerox Spark in Palo Alto and became a head of a team. And in 1970, actually, the first personal computer with a graphic user interface was born. Its name was Dynaboo. The language which they were using was Smalltalk. And Smalltalk became very popular. Smalltalk was used even for the examples in the very popular book Design Patterns, Element of the Reusable Software, Ganko 4. Okay, so after that we know the story. Wozniak and Steve Jobs actually saw also this, and they borrowed the ideas and created the Apple and so on and so forth in the history. Back in 1972, the language C was born, created by Ritchie, while they were working in Bell laboratories on the operating system Unix. Bjorn Strostrup created C++ because C took off and it gained very big popularity. So Bjorn Strostrup combined C syntax with ideas of Simula and probably Smalltalk, and he created a very popular object-oriented language called C++. After that we know the story. In the early 90s of the last century, actually, the language Java was created, and after that Microsoft borrowed the ideas and created C#. So this is the history. Let me tell you something. In this dimension, on this planet Earth, actually it's a spaceship which flies somewhere in the space and nobody knows where we are going, but we still play that very important guys. We still think that we are very important. In our human world we are of course very important. Now, I wanted to say that since we are born, actually we touch objects, we know events, and this is how this computer between our ears is meant to work, because this is actually the biggest curse and the biggest gift to the human race. Okay, so usually our brain works with objects. This is our natural way of thinking. So the question was, can we actually create objects in the computer? Actually, this was the vision of Alan Kay when he actually sold his idea to Xerox Park. He was thinking about programming elements which are like biological cells, which signal to each other but could behave and exist at the same time in such a machine. Okay, so our goal is right now to see, can we create objects? And yes, actually the human beings have been able to find a way to create objects in the memory of the computer. So I would like you to think about the objects like living creatures, like spheres, which exist in the memory of the computer, and they have a pulse, they have their own life, they have properties, and they have their own behavior, like every object on this planet, because the objects have properties and they have behavior. So in this tutorial I'm going to show you how we are gonna create real objects in the RAM of our computer. I just like to think about the very small space shuttle, or a technology which will allow me to look at inside of the computer and go and look at the area of the memory where the object has been created. And I like to think about the objects like living creatures. Okay, I don't want to violate any of your religious or moral understanding, but I just like you to think this way about the objects. We are creating our own virtual world. We are the gods in our virtual reality. Of course, this is a very simplified world, but it's still our own world. Okay, so let's see how with C# we can create objects. Is there a way to create objects and forget about the code and actually think about the objects? What I'm gonna do right now is I'm gonna show you how to create objects in C#. Before we even start, I just want to attract your attention to computer games, 3D software, and even the graphical user interface. Everything in this world are objects. Okay, so without any further ado, as I said, let's start Visual Studio 2012. New project. I'm gonna call this application 1, and I wanna create a console application because I don't wanna have noise. I don't wanna attract your attention with other objects. I just want to start from scratch. Okay, here we go. This is the jungle junction, as I like to say. We just started a new application in C#. C# actually and Java, in fact Java, was the first only object-oriented programming language. In other words, it just enforces you to use the best practices and this paradigm, the object-oriented programming. Even though you still can use the procedural approach, but is not that natural. And C# as the next language, the next level language, actually it's a little bit better. It made some concept more clear. So let's look at now C# and the language. Okay, so we are sitting right now in front of our main function in our first program, and now we can go two different directions. One of them is just think about the code. Think about how with code actually we can create such a virtual world. It's gonna be very difficult, huh? If you try to think in code with if, else, conditional logic, with loops, how we're gonna create such a world, I think is gonna be very, very difficult. But what we can do actually is we can take another way. Okay, let's say forget about the code right now. Let's think about our domain logic, and let's try to create a models of the real objects. Let's create objects. And of course, because we are not real gods, we have to simplify our objects. Let's create one object which is called human. Let's play the god. Let's create a DNA, and after that, from this DNA, create a human. Everything on this planet actually is created first in our brains, and everything has a plan, and after that we build the object, the concrete object. As an example, I will give you the DNA. Actually all we the human beings are from the class Homo sapiens. I don't pretend this is absolutely accurate from the biological standpoint of view, but I want to attract your attention. I just want to show you a way of thinking. So we are all created by the same plan which God created, the DNA. In our engineering practice, for example, we are creating a blueprint of a house. After that, we hand this blueprint to construction builders and they build the house. We can hand this blueprint to another group of construction builders, or even the same group, and they will build the same house. The properties, of course, could be different. For example, one house could be red, another one could be blue, or so on and so forth, but the houses actually are built from the same blueprint. And because we, the human beings, actually we are limited, we just copy this dimension, the things we know from this dimension. I just want to mention something else. Why the computers actually work with binary code? Why don't we use the decimal? This comes again from our technical limitations. In electronics, it is much easier to create flip-flop logic or devices with 2 stable states instead of 10 stable states or whatever. So that's why actually was very difficult initially for us to start, and we had to use the binary code, only zeros and ones. Okay, so now, as I said, I'm gonna take another way and I'm gonna think about objects. I'm not gonna think about code so much right now. So just one technical thing. I just want to see that my program works. So the first thing I'm gonna do is hello world. I want to print on the console hello world, just to make sure that my program works. As you can see, it has been executed and after that closed. So I'm gonna use again console read, just to make my program wait for me to press a key on the keypad, on the keyboard. Start and hello world. Probably you see it. Okay, so now I'm gonna hit enter. Okay, now so we're sitting in front of our Visual Studio, and now what I'm gonna do is I'm gonna create my virtual reality. Okay, I'm gonna click on the Solution Explorer, and after that, you know that in Visual Studio there are solutions as a container for different applications. So in this container, solution application 1, I have an application which is called app1 at the same time, so with the same name. So I click with the right mouse button and I will choose add, and I'm gonna choose a class. So the classes are the syntaxis tools of this language, which will allow me to create the blueprint, the recipe from which the computer after that is going to build one object. This is our plan. This is our blueprint. Class, and I will say human. Of course, our human is going to be not that unique and not that special as the ordinary humans are. Our human is going to be simplified. We'll abstract the term human. We'll say that all properties we need to describe a human are only the name and the age. Okay, so the class, in other words, the blueprint for creating an object in the memory of our application actually has been created by Visual Studio, class human. Now, let's create one living creature in our application of class human. Let's say, okay, let's build using the blueprint human, let's build one object which is a real existing thing, entity in our application. How we are gonna do that? When we define a class, this keyword, when we use this keyword class, what happens actually, we're defining a custom class. They're primitive types, custom type. They're primitive types like boolean, integer, float, double, string. String is not that primitive, but we'll talk for this later. Okay, so we have primitive types which we have with the language. By defining our own class of objects, we are in fact creating a new custom type. So that's why my variable is gonna be of type human, and I'm gonna call it person1. And here we go. With the keyword new, we create one object of class human. Actually, what we are telling the computer is, okay, instantiate, because this process is called instantiation of an object of a class human. Okay, using our blueprint human, actually create one object. The first row, where the keyword class and the name of the class is, it's called declaration of the class. And curly brackets are called the body of our class. Okay, in any case, let's show you that the human actually has been created. Of course, I'm not going to show it on the screen, but you can imagine that one capsule, one object in our memory has been separated from the rest of the memory, and the human, this living creature, actually was created inside of our virtual reality. So let me show you that. Let me show you that when I run the program, actually we will have this human being. Of course, is not manifesting its existence by any mean. I mean, we cannot see it, we just can imagine. It is in the memory of the computer, but just imagine that we have a newly built creature. Human person2 equals new human. So what I'm showing you here is how to define a class, and after that how to produce an object of this class. Okay, right now I have two persons, even though they don't have individuality, they don't have anything special which can allow us to separate them from each other. They're absolutely equal, they're absolutely the same right now, person1 and person2. They look exactly the same. One object in the real world actually has properties and also behavior, and I'm gonna show you how we are gonna model the behavior and the properties of our human. And as I said, a human will simplify the human, because the human beings have color of the eyes, color of the hair, they have other properties and behavior. We will simplify our human. We will say that for all the properties which a human being actually possess, we need only name and age. That's all. Okay, let's start the program just to make sure that we have built two objects, and even though we don't see them right now on the screen, they exist in the memory of the computer. Just imagine that with a very small shuttle, or we have a technology which allows us to go inside of the computer and look at the RAM. This person1 and person2 are pulsing, they're existing in our virtual reality. Okay, so let's continue further. Let's try now to declare properties somehow, to attach properties to these two human beings. Okay, the language, this language C# actually allows us to do that by declaring so-called fields. The fields are variables which are declared in the body of the class. They are not local variables of different methods, functions. They are just declared in the body of the class. So let's try. String name is gonna hold the name of the person, and integer age is gonna hold the age of the person. Okay, let's try to assign values. Person1 oops, what's going on here? Look, if you look at, you'll see that there are no such properties. We cannot access these fields. We cannot assign the properties. It's exactly like in the real world. The person doesn't allow anybody to change its name or its age. The object is encapsulated and keeps private the internal variables. So exactly the same way, by default, the fields are private, so we cannot access them from outer world. But we said that we want to keep the properties somewhere, and this is one possible solution for us using the fields. So let's allow everybody actually to change the values of the name and age by using a special modifier, access modifier called public. By default, as you can see, actually the fields are not accessible from outside world, but we want to keep the properties of our objects in these fields. Fields are nothing else, I will repeat again, but variables declared in the body. Okay, so now name, and I will say Stoyan. So let's make this persons with a name and age. Person 1 age equals 50, and after that person 2. So now they become persons. Before they were just little babies which we have created in our virtual reality, and they didn't have names, they didn't have age. But in the world of the human beings, actually we like to attach labels to every object, and especially to ourselves. So that's why using the properties to assign the name and the age. Let's say the second one is Ivan, and person 2 has age of 20. Okay, so let's start the program and make sure everything works. So now let's show our objects. Let's show that they exist. So I'm gonna use again console write line, and I'm gonna say my name is, I'm gonna put a placeholder here, and after that I'll say I am years old. Okay, person 1 name, person 1 age. I like to think about the objects like the real creatures which exist in the virtual reality, because this way it's easier to understand the concepts. And I will introduce the second person the same way. It's very easy right now. I'm just gonna say person 2, person 2. Okay, we have discovered the programming tools which will allow us in the language, which will allow us to have one object with properties. We said that how we want to describe the objects from the reality is by having properties and behavior. So this is one way actually to assign properties to our objects. In the beginning I show you that even without any properties and without any behavior methods, which we'll look at just in few minutes, without properties and behavior, actually the objects still can exist. And how many objects actually can we create until the random access memory is over? Probably we can create 6 billion objects or something. I haven't tried that, but of course we can try it. You can try it, of course, if you like. Just create one array with a lot of elements, for example 6 million elements, and in a loop try to instantiate objects and assign them to different variables in the array. Okay, in any case, different indexes. Okay, let's see if our objects right now exist. Here we go. They exist and they introduce themselves with different name and different age. Okay, so we have two different persons which exist separated from each other. They all are from the class human, and that's why they have the different properties, but the values of the properties are different. Okay, we have started to experiment with this model, and very soon we discovered that using the fields, variables declared in the body of the class actually, and representing the properties with such fields is not a very good idea. Imagine in the program everybody being able to change these properties, the property of an object, without any criticism. This is not a very good idea. This is not a very good practice. So the next step actually we made was to represent the properties with two different methods which are called accessory methods, or getter and setter. And the good practice is just to make the fields private. Exactly like in the real world, we don't allow somebody to change our name without any criticism, without thinking. The very same way we don't allow the properties to be changed so easy directly by anyone. Private. So the best practice says of the OP says just make them private, and after that define methods which will get and set the values of these properties. In fact, for the internal viewer, the property is going to be represented by two methods. Okay, let's do that. Public string get name, and we'll return name. After that we have public void set name, and we are gonna send as parameter a string name. Name equals name. Oops, do you see the problem here right now? Okay, we have a member variable, or instance variable, or field. Those three terms actually are used to describe this variable which is declared in the body of the class. Okay, I'm gonna call it further just a field. So the name of the field is exactly the same like the name of a local variable. In this case, it's on top of that a parameter, formal parameter, some people call it. Okay, how to solve this problem? Actually, this is called scope overlapping. And now the local variable overlaps the field. So, in other words, we're not doing anything here. We assignment made to same variable. It doesn't make any sense. That's why in such languages for object-oriented programming, a special keyword was introduced. It's this. Okay, when you say this, that means you refer the instance, the concrete instance created by this class. And what we say here is, listen, when I say name, this name, I mean this field. And this name is actually the local variable. So now it makes sense. I just introduced another term, which is the keyword this. The this is reference to the instance, to the object itself. This is what this means. Okay, so right now the property has been represented by a couple of methods, getter and setter, call it accessory methods. I will do the same for another property, age. Age, of course, this is integer, return integer, oops, not integer, of course, age, and here is gonna be age, and again we will assign to this field age. So the values of the properties actually are kept in the fields. It's not a string, it's integer, of course, and voila. Okay, we did our first refactoring. Refactoring is called a process of improving the internal structure of the code, making it more clear and simple, easy to read by somebody else, without changing the functionality of the program. By the way, let me tell you that one principle: everybody can write a code which the computer can understand, but not everybody can write a code which another human being to understand. And our goal is to create a code in such a way which allows another human being to read our code. The cost of change after that decreases tremendously, because everybody can add functionality, everybody can find everything in our code. Okay, so let's refactor right now our main function according to the changes we made in our class human. So we say set name, and we are setting the name because right now we have accessory methods to represent our properties. Set name, set age, set age. We'll do the same for the second person. Set name, set age, set age, and after that I'm gonna say get name and get age. The same for the second person, get name, get age. Okay, set age, set age, probably I made a get age, set age. Okay, hopefully you see that, because my resolution is very high, and but at the same time I just want to keep it for now. So this is how the code looks right now. Okay, alt, of course, I wanted to say alt here, made a spell mistake, alt. Okay, let's start the program, and you'll see the code, actually the result looks exactly the same. So we have done our first refactoring. My name is Stoyan, I am 50 years old. My name is Ivan, I am 20 years old. Okay, we just improved the internal structure of our code without changing the functionality. Okay, let's go back. Now, that's very good, and that's perfectly acceptable for languages like Java and many other languages, for example PHP as well. So we represent the properties using the accessory methods getters and setters. C# actually offers us a special construction, syntaxis construction, which allows us to create properties, to define properties and use properties of the objects without actually writing so much and without using methods. I just introduced methods, even though I haven't spoken about them, but they're so important that I just had to introduce them. I had no other choice but show you how to create methods before show you the properties. The properties are something between fields and methods. Methods are nothing else but functions which are defined in the body of the class. That's it. Okay, so let's make it simpler. Now, I'm gonna comment the accessory methods and I'm gonna show you the special syntax which allows me to define properties without using methods, because the methods later we're gonna use for describing the behavior of our object. And really it's a very good idea to have a special syntax construction which allows us to define properties, because they're separated from defining the behavior using the functions or methods. The function which is declared in the defined in the body of the class is called method. Okay, so let me show you that. Public string name. Look, I'm not gonna put parentheses here because this is a property, but so it looks almost like a field, but we have curly brackets, and inside I'm gonna define getters and setters. Get return name, and I'm gonna define set name equals value. Pay attention to the special keyword value, so we don't even have to use anymore the keyword this. Set name value. Okay, less code and conceptual difference between a method and the property. Now we are not using the methods anymore to define our properties, because the methods should be used to describe the behavior of the object. So that's why in C# there are different syntax constructions. In Java we still use methods to describe our properties. H return, of course this should be int, integer, return h, and h equals value. Okay, so another step to improve our code. Now refactoring will look like that. h50 set name, Ivan, and h. Some people say that some people prefer actually to use properties like that. Even though there is such syntax construction in C#, you still can use the alternative and represent the properties with a pair of methods, getters and setters, accessory methods. Okay, here name and age. The same here for the person number 2, name and age. Okay, so we better describe the properties. Okay, let me start the program, and I'm gonna show you that the functionality actually haven't changed, but has not changed, but we improved the understanding of the code. If somebody else reads it, it's gonna be better. It's gonna be better understandable. Okay, let's take a look now. What else can we do? Now, as you can see here, we first create the human being, the object, and after that we give the human individuality. We set the properties. Wouldn't it be better if during the instantiation we actually adjust our object, we set the properties? Yes, there is such a way, and it's done through pseudo functions called constructors. So a constructor is a pseudo function, pseudo method, which doesn't have a return value and has the same name as the name of the class. So I'm gonna create right now one constructor which is gonna allow me to set the value of the fields. Public human string name integer age, and I'm gonna set this name equals name and this age equals age. Now let me tell you a secret. Now as you can see, we cannot construct, we cannot instantiate any more objects from such class without giving extra parameters, which are the name and the age. Why? Because we have defined, declared and defined one constructor with parameters. We don't have a constructor without parameters. Let me tell you a secret right now. Even though we don't define a constructor in the body of the class, the constructor is added by the compiler. In other words, implicit, the compiler creates a constructor which looks like this. Public human, it doesn't take any parameters and doesn't do anything. So the constructor always exists even though we didn't define any constructor. The catch is that once we create a constructor, as we did, we're telling the compiler, hey listen, I don't want you to add anymore a constructor without parameters. I'm in charge. I will decide, shall I define a constructor without parameters or what type of constructors I'm gonna define. So the default constructor here is not added anymore implicitly by the compiler. In other words, we cannot instantiate any more objects of class human without giving any parameters, because we don't have a constructor without parameters. We just have to give the name and the age for both. If we want to have a constructor without parameters, we explicitly have to define it like this. Public human. In this case, an object can be instantiated without any parameters. Right now I'm not gonna do that. Just gonna leave the constructor with parameters. Okay, so now I have to give parameters right now during the instantiation of the object. Stoyan, and I'm gonna give age 50, and I'm gonna do the same for Ivan, and I'm gonna give age of 20. Right now we don't have to set explicitly here again the very same properties, so I can remove these properties. I don't need them anymore. I just will use the properties to get the values of the properties. Okay, so the fields where the values of the properties are held actually will be already set up for me during the instantiation. Let me try and see. Yeah, here we go. As you can see, both objects, both persons introduce themselves the same way. Actually, they don't introduce themselves, somebody else introduces them. Okay. Now, what else can we do right now? Right now, our humans, our persons, actually doesn't have a behavior. They don't know anything. They don't know how to act. They don't know how to do anything. Let's teach them to do something. Because what happens is something like this. One person enters the room and just cannot say anything, doesn't speak English, doesn't speak any language. Somebody else In this case, I'm delegating this to the main function of my program. So the main function of my program actually turns to the person, looks its property name, looks its property age, and just reports to everybody, to the rest of the world. Okay, my name is, and I'm, in fact, I should say the name of this person is, and his age or her age is. This would be even correct, more correct. But I want to show you something. So right now I want to teach my person how to do something. I want to create closer to the reality model. In other words, I'm gonna describe a behavior and what are the program tools I can use in this case. Those are methods, functions which are defined in the body of the class. I will delegate this to each one of the persons. I will delegate introducing himself to the object. I'm gonna say public void, even though I wouldn't do that. I usually will return the string. Public void introduce yourself. Even though it's only one word, I just type it, introduce yourself. And after that I will copy the code, change it a bit, and show right now person name and age. Okay, so I just teached my objects how to do something. I don't need anymore this console. I don't need somebody else to introduce them. I don't need somebody else to know their properties very well. I teached my objects themselves how to do something. So defining a method actually is like teaching the object to do something. Okay, now I can say person1 introduce yourself. Look, my method just show up. Person2 introduce yourself. You will see that the functionality is not gonna change at all, but I just changed drastically the internal structure of my code. I made it better. Why the code is better? Simply because the cost of change will be very low. Right now, if let's say I want to change the way the persons get introduced, I don't have to go to 100 places in my program. Let's say that on 100 places in my program I have to introduce my persons, so I don't have to change the code on 100 places. I just go to one single place in my program and change the code, and after that everywhere in the program this change will be seen. Okay, so this is the next improvement I have done. Now I want to attract your attention to another detail. I may have a property which doesn't have a field where I keep its value. Let's say this is a financial software, so I have a property balance, but the balance is not a written on stone value. The balance each time gets calculated based on the day and, if you wish, the hour when we are getting the balance. It's based on another calculations. So let me show you that. Public double balance, and this is a property, and as you can see I don't have a field here where I keep the balance, because the balance each time gets calculated based on some properties or other values. Okay, and here we go. the super duper complicated calculation. Get two multiplied by 2. After that I will make it a little bit more complex. I just want to show you I wanted to show you that actually you can have getters and setters in the properties like we do here for the rest of the properties, but we could have properties which have only getters or properties which have only setters, and this property doesn't correlate to any field in the class. Another thing which I wanted to show you is that you actually can have a field which doesn't expose its value to a property. Let's say we need a container, a variable where to keep a temporary value which probably will pass between different methods. For example, so as you can see, temp is a field, but we don't need such property. We don't need property temp because to describe the object we need only these properties. Temp is not a part of the description of the object, is not a property of this object. Okay, so this is what I wanted to show you, and as you can guess, nothing changes in our program. Actually, it keeps working the very same way. Now the next thing I wanted to show you is how we can create more constructors. What we can do is actually define methods with the very same names but different parameters. Even if we change the order of the parameters, this is gonna be a different method. The name of the method plus the parameters and their order create so-called signature of the method. And we can not have methods with the same signatures. This is in power for the constructor as well. So let's create a constructor without parameters. So I will say public human, and notice something right now. I'm gonna call the constructor this way, and I'm gonna say that my default, the name of my default user, if I don't give any parameters when I'm instantiating an object of class human, in other words, I want to be called the constructor human with such parameters, with age 0 and default. This is another concept which I wanted to show you. I spoke already about the method overloading. Overloading method means defining a method with the very same name but different order or type of parameters, or formal parameters. Okay, let's try and create a person number 3, human person 3, and this time let's use a constructor without any parameters, and I bet his name is gonna be default and his age or her age is gonna be 0. Let's prove that. After that we're gonna finish with this tutorial. Okay, introduce yourself, person 3, of course. Okay, let me run that, and here we go. Okay, so the constructor without any parameters actually called the constructor with 2 parameters and sent as the values the name default and the age 0. So such person was created. Such object was instantiated, and the object was set up with the name 0, with the property 0, and h0 with the h0 and the name default. Okay, let me make a summary. Like a fairy tale story, actually I introduced to you the elements of the class. The elements are 6. So this is the declaration of the class. The body of the class is closed between the curly brackets. This is the second element of the class, the body. The third element of the class, which I show it to you, is the field. The fields are variables which are declared in the body of the class. The fourth element are so-called properties, a special syntax construction which allows us to define properties. The fifth element are the constructors. The constructor is a pseudo method. It is a pseudo method because it doesn't have a return value, could have parameters, and its name, it's exactly the same like the name of the class. So this is the fifth element, and the last element is the method. It's a function defined in the body of the class, and it represents its behavior. Okay,